go. So first off, we're going to practice some plain old-fashioned factoring. I hope this is insultingly easy. Factor that. A surprising number of kids think factor, every time you hear factor, that there has to do two parentheses. No. There doesn't always have to be two parentheses. In this case, do you agree that there's a 2 in both of them and the 2 can come out? And then you have x plus 5. But what did you really do there? What you really did is you divided both of them by 2, and that's how you got your x, and that's how you got your 5. See what I did there? Do you agree that that factors to this? That make sense? Okay. Now, when would you see this with trig? Well, it would be something like this. Sine x plus cosine x sine x equals 0. Write that one out. Factor it. It's just like the other one. That's why I did the other one first. That's called scaffolding. Building that up so that you could be like, oh, I see how that works. So that you can more easily access this difficult one. Now, another thing that's so critical. One of the reasons that I have you do this is that if I say, hey, do you guys have any questions? A kid, nobody will ask a question. Well, sometimes I get one, and that's wonderful. And then if I say, hey, talk to your partner about this, a lot of times people will ask that kid. They'll be like, I don't get what he's talking about with this. And they won't say it to me, but they'll say it to the kids. So that's one of the reasons it's really important to be able to talk to and open up to your partner. So I'd love for you to take a second and tell your partner or ask your partner what's going on this one. Please talk to the person across from you. You're going to work with these two guys behind you. They all have partners. So just work with the road. Kind of a noun. All right, I'm going to have you, just for today, you move your back right there, but would you move right up here? That way she's got a partner. All right, here we go. Sine x was the common factor. And if you underline it, it's kind of smart. Let me show you why. Because then you go, sine x is the common thing that it can factor out. It's called the GCF. And then really what you're doing is dividing by it. So when you underline it, it's kind of like you just made it into a fraction. And then you can just kind of go like this and go, well, what would this be? 1 plus, what would this part turn into? 1 times the cosine is cosine. Raise your hand if you had that one right. Awesome. Now, that's just the factoring part. Now, we've got to be able to go, oh, so this part equals 0, and this part equals 0. And that makes circle trig problems. And within the equals 0, that's not sides of a triangle, because you can't have a side of 0, so then it must be quadrantals. So try it from this part on. Again, if you're like stuck on one, ask the kid, what do you do on this one? I'm hoping that with enough practice, I want to just tell you a story that I found inspirational. How many of you guys have heard of Caitlin Clark? All right, most of you have. She's just an amazing college basketball player. She's just awesome. And just hitting these incredibly long three-pointers. And you know why she's so good at that? You know what she does for a workout, just like in her spare time? She shoots 300 shots. Some of you guys have been basketball players and have never shot 300 shots ever on a day. She goes and does an extra 300 shots. And not only that, you know, when you're shooting, when you're all relaxed and like not tired, that's not that hard. She does sprints first, and then she shoots 300 shots. So my point, I know you should know how to do this already, and I'm making you do it again? Yeah, because you should get fluid at it. Like, I'm not going to make you do 300 like she does, but that's how you get really fluid at something. Just should be like, oh, this is easy. I can just go -1, -1, Cosine x equals -1. That feels like a quadrantal. This one's definitely a quadrantal. So sine is 0. I hope you start thinking y over r. Y is 0. Where's y 0? That's a spot where y is 0, but so is this. So there's two answers for this. How many of you knew that those two were the answers for that? Okay, awesome. And that's 0 and pi. Now over here, this one is cosine is -1. Is this a triangle possible? No, because the hypotenuse is the same. You know, this would be adjacent over hypotenuse. Hypotenuses can't be the same as the other sides. They have to be bigger. So then that can't be hypotenuse, so therefore that must be a y, or x over r. And it must be a quadrantal. And which one has x is -1? I can start getting better at just going right to it. That's where x is -1. So it's got to be that spot. We already had that spot, so it's pi. Now, does it change that fact that there's two of them? No, it's just pi makes both of them 0. So it's 0 and pi and another pi, but you don't list it twice. You just, the answers were 0 and pi. Raise your hand if you would have got that one right. Sweet. Okay. Next kind of factoring I want to explore is x squared minus 1. Don't overthink it. Just factor it. If you don't know what to do, it's because you haven't practiced this enough. You haven't done enough top 20s. This is on the top 20. X plus 1, x minus 1. So why is that in this unit? Because it'll be like sine. And the squared then happens to go over here. But now, factor it with that. And we'll set it equal to 0. So it's sine and sine. Are these the exact same little equation as each other? They're close, but are they the exact same? No. So then you have to do this twice now. Sine x plus 1 equals 0, and sine x minus 1 equals 0. All right, solve both of those and get it all the way down to a circle trig question. And you might have 2 or 3 different answers total when we're all done. I'm in trouble focusing today. I need this. Are you done already?
Yeah.
You really? Oh my gosh, that's amazing. All right. Turf, can you take it to the next step? Yep. Sine x equals -1. Which of those is that? Yeah. Yep, because that's 0, -1. That's the spot where y is -1. And you probably already knew it was y over r. Okay, good. And that's 3 pi over 2. How about the other one?
Sin x equals 1.
And then what?
It would be the top one, so 1 pi over 2.
So that is pi over 2. I have 2 answers. 3 pi over 2 and pi over 2. Who had those answers? All right, good. Next kind I want to talk about. Factor this. A lot of people are going to think you should divide by x squared. You cannot. You have to get it equal to 0 If you divide by x squared, you get it equal to 1. You don't want to do that. So you want to subtract x squared. Lux, after I subtract x squared.
Then you just have x. Wait, no. Then it's x cubed minus x squared.
Yep. And then can you take it from there?
Then you can divide by x squared, so you get x minus 1. Or, yeah, x minus 1.
Yup. And now, imagine a world where this had sine on it, or cosine on it. Do you get it be the same thing? This would just be a sine squared x, and this would be a sine x. So let's do that. Everybody just cheat. At the end, we'll just put in a sign here, and our squared should really be in there. I know, I just changed the problem, but that's what it would be like on the test. We're not going to give you one just like this. It's going to say sine and sine, and the cubed will be here, and the squared will be there. So there's what it looks like. Now can you finish it? Well, I hope this one's like, well, that was easy. That one might be a little harder. You make a little equation for both of them. All right, I'm going to give you a minute on this one. And I bet you there's going to be a ton of people that make a little mistake. So watch out. If you feel like it was super easy, there's a gotcha in here. Pause. Okay, so we set them equal to 0. And this is the part that's got the gotcha in it. And we set this equal to 0. And you add 1 to both sides, and then it's sine theta or sine x equals 1, and then that's a pretty normal one. Where's sine equal to 1? That's where y is 1, and it's that spot. So it's pi over 2. There's no gotcha there. But this side, how the heck do you do that? Do you know how to get rid of a squared? Square root. So I think some of you knew to do that. And here's the catch, though. Square root of 0 is just 0. That's no problem. But do you remember when you do square root of a variable, then it's the absolute value of it? All these things that I taught you, you have to remember all of them on this test. And so then that means there's 2 answers. Wait, but it'll be sine x equals 0 and sine x equals negative 0. Isn't that going to be the exact same thing? Yes, but I'm warning you, later this hour, if you don't do this absolute value thing on a different problem, there's 2 answers and you'll only get 1. Got to remember it's absolute value. I'm going to go off to the side and show you where you got taught wrong back in the day. Your teacher back in the day said square root, and they just said this was x, and they lied to you. And then they said plus and minus 4 here, and they lied to you because the square root of 16 isn't plus and minus 4. The square root of 16 is just 4. They did that because it was easier than explaining, or maybe they don't know, that this is the absolute value of this, and the square root of 16 is just 4. And this is why there's 2 answers, because absolute values give you 2 answers. So my point right here, if you square root and you just act like there's no absolute value, then if this had been a number, which it will be later this hour, then if this had been a number, you'd have to do one with it positive and one with it negative. But the square root of 0 is just 0. So if you don't remember these absolute value bars, it's going to toast you on the test. Why? Because you did the square root of a variable. See, you did the square root of a variable. Okay. So again, at the end, this would be sine x equals 0 and sine x equals negative 0, and we all know that's the same thing. So, okay, there's only one this time. But if this had been a number like 8, then you'd have to do positive 8 and negative 8, or more likely 1. If that had been a 1 there, then you'd do it once with positive 1 and once with negative 1. We'll see if you remember that literally like 5 minutes from now when I throw up another problem that's like this. Okay, but let's finish this one. Sine is 0, that means y is 0, and where is y 0? Y is the up and down, so then this one's got a y is 0, and this one's got a y is 0. So both of them are the answers. That's 0. Don't say 0 degrees, because the answer has to be in radians. So just 0 and pi are your two answers for that one. This one had an answer of pi over 2, so those are my three answers. Pi over 2 and 0 and pi. All right. Now, a more normal one. Tangent of theta minus 1 equals 0. Solve. See, this is the part where if you're really fluid at this, it's no big deal. You just add 1, tangent equals 1. Well, that's great, Mr. Server, but I'm not feeling really fluid about these. Then you should come in the morning and get some help. This morning was a good morning, Thursdays. Next week, Thursday again. You'd still have time to come in and get that help, but during work time today, you're going to have some time, and you're going to be stuck on something. Will you come up and ask me? Well, we'll find out. Okay, so tangent is 1. Is it one of the quadrantals? No, it's not. Why not? Because it's 1 over 1, and tangent is y over x. Is one of these spots at 1, 1? No, that wouldn't work. Another way to think of it is tangent is opposite over adjacent. Can you make a triangle like that? Yes, you can. So then you got to go ASTC circle. Figure out which quadrant you're in. Who's already got the answers? Since only 3 people have got the answers, take a second right now. Draw this triangle in the right spots, plural. Figure out your 2 angles. I'll pause for a second, and then I want you to compare with the kid next to you. Ask them first. Like, are you done? And if they're done and you're done, see if you did it in the same quadrants as them. It's kind of weird. They're not like right next to each other. And then see if you get the same angles. I'll pause while you finish that up. Okay, so tangent is positive. You know, there's no negative in the front of it, so it must be positive. So then I must be looking for the spots where tangent is positive. And so I could draw a triangle here and here. And then if this is 1 and square root of 2, Brody, can you put that in your backpack, please? This is a 45-degree angle, which is the same as a pi over 4. And then this is 4 pi over 4 plus a little more, 5 pi over 4. Raise your hand if you had those 2 answers. Okay, good. So next up, or sine squared x minus 3 equals 0. The whole point of solving an equation is to get this x alone. But when you're in trig, you're trying to get sine x alone. So get it all the way down until sine x is alone. I'm going to pause for a second.
Factor out 2 sine and 2 sine.
Nope, it does not factor. I love that you thought about factoring it, but it doesn't factor. I guess I could be wrong, but I don't think so because there's no middle term. So 98% chance that I'm right on this, it doesn't factor. So then if it doesn't factor, Graydon, what do you think I should do to start with? Okay, I love that you were thinking about factoring. That's awesome, because later on in the hour, there's gonna be another factoring one, but you start by adding 3 to both sides. I don't believe you can do this by factoring, because there'd be a middle term, and I'm pretty sure you can't make the middle term just cancel on this kind, so 4 sine squared x equals 3. Next, you divide both sides by 4. How would you know to do that? Because I know that I'm trying to get sine alone, and now sine is almost alone. It's just squared. Xavier, how do we get the squared off of there? Excellent. Ainsley, I'm going to trust you for this one. What do you think I do after I do the square root? Oh, boo. Okay. Somebody, step up. Show me that you got this.
Absolute value.
Absolute value. Do you have a short-term memory? He does. You just did the square root of a variable. You have to do the absolute value. Now, it's another tricky part. Do you guys even know that this is the square root of 3 over the square root of 4? You're allowed to do that. It's the square root of both of them. And why is that good, Brody? Sorry, Bodie. I've got a kid named Brody. It sits right there. Sorry, keep going. So, what does it simplify to? This part simplifies especially. It is a root 2. Or sorry, the square root of 4 is 2. And then the square root of 3 is still on the top. And look at that. Have you seen that combination before? Remember the triangle that's got the 1 and the 2 and the square root of 3 in it? Does that ring a bell? That's why that one worked out especially nice. Okay, and then this absolute value thing, what is that? Well, you learned it before. I told you that it would come up at least 3 times on tests this year. You really got to remember that the absolute value thing is a big deal. So here it is again. And it splits it into 2 problems. Sine x has to be square root of 3 over 2. And the other one is sine x has to be negative root 3 over 2. 2 triangle problems. These can be triangles. They're not quadrantals. Figure out where to draw the triangles. And in the end, you want angles. And usually there's 2 angles for each of them. That means there's 4 answers. You have to step up this unit. This is not going to be a walk in the park. But as long as you're trying really hard right now, and then tonight when I ask you to do literally only 5 homework problems, problems 1 through 5 on the worksheet, you got to be willing to do a little practice tonight. It sets it in your brain. If you just take 24 hours off, you lose a fair amount of what I taught you today. If you just take one time tonight and touch it for a few minutes, practice a few of these, it'll stick so much better. And in a hard unit, you really need that. I would every single time I make this part of my practice, just like Caitlin Clark makes it part of her practice to shoot 300 shots, not free throws either. These are like from out in the boonies. And that's where sine is positive, and so is that. And this is out and this is out, and these should be just easy for you. This angle right here is across from the square root of 3, and that's not pi over 6, it's pi over 3. Raise your hand if you had pi over 3 as one of your answers. Sweet. And then a bunch of pi over 3s. Well, it's not 3 pi over 3, that'd be here. It's 2 pi over 3. So I got pi over 3 and 2 pi over 3. And then here, it's basically the same thing, it's just that it's in the negative spots. So it can't be up here or here, it's got to be here and there. And I'm not even going to label my sides because I know that it's going to be the same. It's going to be pi over 3s. If you wanted to label the sides, you can. I'd understand it. But I know that they're going to be pi over 3s. So I'm going to go, that's 3 pi over 3. So one more, it'll be 4 pi over 3.
And is this 5 pi over 3? I think so. I just go to the next one and go, that's 6 pi over 3. Yeah, that if that's 6, this must be 5 pi over 3. So my answers are 1 pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Did anybody get that without my help? All right. That was like half the class got that without my help, and that's awesome. Okay. Now there's a couple more, but then we'll have some work time after that. All right, so this one's another just basic factoring one. Okay, I lied. It will be a basic factoring one if we can somehow swap out and get the same function in there. Like if those both said sine, I'd be starting to factor it right now, but they don't both say sine. So do you remember on the last test where you could swap out something? Guess what? You know that sheet we gave you before? You're going to get it again for this test. So you'd be able to look on the sheet, and the one that has sine squared in it is this one. Sine squared plus cosine squared equals 1. So can I get sine squared alone and rearrange this thing so that sine squared is alone? Yeah, I just have to subtract cosine squared. And look, sine squared, after these cancel, is 1. And that kind of looks like a plus because of my box, but 1 minus, oops, 1 minus cosine squared. So you put 1 minus cosine squared here. Now, I did that because I knew that at this point in the hour, your brain's getting fatigued, and I wanted to get you past that. But now, multiply this all out, and you're going to have a negative 2 cosine squared in front, so I'm going to even give you one more little piece of help. You have to factor out the negative 1. Once you get this all simplified down, it'll have a negative in front. You have to factor out a negative 1, and then you'll be able to factor it. Hey, you're the one who decided to take precalc. You could have taken FST. It would have been a lot easier. But you ostensibly wanted a challenge. This 2 here is not negative. Do you agree that that 2 is positive? This 1 here is also positive. Do you get they can go together and make a total of 3? See, a lot of people think that's a negative 2. The negative is on this 2. So, when I move these two together, they are going to make a total of 3. Negative 2 cosine squared x minus cosine x plus 3. And then what did I say to do? Who's got a short-term memory? Come on, somebody. Factor out the negative. Factor out the negative. Do it. And then you'll be able to factor it. See why this is the most retaken test? You can't just avoid it. Test is coming. If you're going to be like, yeah, well, okay, fine, I'll just fail it and I'll retake it. Yeah. Then you're going to have to go relearn all this stuff then. Or you'll just have to live with a D in the grade book. That wouldn't be worth it. So you have to take the time and fight through this stuff now. Retaking it takes you an extra minimum 2 hours, and I would submit on this test, you need to study for like an extra 2 hours and then take the test. So that's gonna take you 3 more hours. Why not put in an extra 15, 20 minutes each night to do your homework and recheck it thoroughly, and then maybe you won't have to do a retake. All right, Brady, can you tell me, after I factor out the -1, what goes in here and here and here?
2 cosine and sine.
2 cosine squared. Now what?
Cosine.
Plus, being a little, you gotta include all the little details, like the squared and the plus, and then what?
-3, sorry.
Okay, good. There, we factored out the -1. We don't do that very often. You have to know how to do that. Why did we do that? Because now you can factor this part. You wouldn't have been able to if you hadn't factored out that -1. It would have been a nightmare to try to factor it. Now it's just doable. You can start with 2 cosine and cosine. Just take one little step at a time. And then you figure out your signs. Is it plus and plus? Is it plus and minus? Is it minus and minus? And then you figure out your numbers. Ainsley, was it plus and plus or plus and minus? Plus and minus. And then the 3, did you put the 3 in the first spot or the second spot? 3 and a 1. And did you check it to make sure it worked? Awesome. Then this, wait, that's the wrong ones to check. Sorry. This and this, 3 cosine x. And this, -2 cosine x. And together, does that make 1 cosine x? Yes, it does. Look at that. I factored it. Oh, you actually factored it correctly. After all that work, you're still not done. Because now you got an equation for this and an equation for that. But I'm going to save you time. Just skip that one. It would end up being complicated. You have to leave your answer with, honestly, we do that in honors, but you wouldn't have to do that one here. So you should definitely be able to do this part. Okay, talk to that kid next to you. Make sure they're done first. Pause for a second. Come on, talk to the. Okay, so cosine is x over r. Is there a spot where x is 1 and the radius is 1? Yes, there is. I think it's this. Do you guys agree? So then the answer is 0. I hope you didn't say 0 degrees, because the answers have to be in radians. I know that 0 degrees and 0 radians are in the same spot, but if you said 0 with a little degree symbol, it would be wrong. I'd have to take off minimum 5% for that, because it's got to be in radians. So it's just a 0. You don't have to say rad or anything. Technically, radians don't have a unit, so you just say 0. It's complicated stuff. All right, so then there's one last one, and this is kind of a big deal. And that is, actually, this should be an easy lead up to it. 4, that's a 4 in front. 4 sine squared theta equals 1. I hope this is like, yeah, we did one like this. Not that hard. Square root's involved. I remember the absolute value. I can get my answer. Dominic, what did you do to both sides?
-1.
Good try. I know you're thinking set it equal to 0, and I love that, but I would divide both sides by 4. Why? Because I'm trying to get the sign alone, and I can unsquare it by doing square root. Your way actually might have worked this time. If you had factored it, it might have actually worked. But this way will be faster. I'm now square rooting both sides. Did you remember absolute value? It's not that hard. You just got to remember when you square root a variable, slap the absolute value on there. But at this moment, a ton of kids will just be leaving it as square root of 1/4, and they're wrong. Rissy, I bet you did it right. What did you change all of that into? All right, what is the square root of 1? Yeah, so 1/2. And you're right, there's two parts. Sine theta is 1/2, and sine theta is -1/2. The only reason I corrected you is because you don't want to leave the square root of 1 in there, because square root of 1 is just 1. You were right that it was the square root of 1 over the square root of 4. And that simplifies down to 1/2. I hope that these become quick. Sign's positive, so must be here and here. Sign's opposite over hypotenuse. What's across from the 1? 30, aka pi over 6. And then this is a bunch of pi over 6s, so 5 pi over 6. And then this one's negative, so then I cross these out and I draw them here and here. And then they're also pi over 6s, I already know from this. So then I can say 6 pi over 6s plus 1 more is 7 pi over 6. And then it isn't all the way to 12, so this was 11 pi over 6. And there are your 4 answers. Now, this unit is hard enough that I just have decided I have to schedule 2 morning helps next week. It's going to be Tuesday morning or Thursday morning. And then there's still a few kids that are still missing the last test, and I'll give you extra times to take it. And so I'm going to offer up my extra help Tuesday morning and Thursday morning next week. So if this is kicking your butt, come in and get some help. All right, now I got to show you one last thing. And I know your brain's exhausted. Don't even write this. Just watch. I'm going to solve this one, and I'm going to show you why there are extraneous answers in it. So there's 2 parts. It's already factored. So tangent theta has, oh, I did this wrong. I apologize. Hold on just a second. 0. Okay. Tangent theta equals 0 and sine theta equals 0. Are you with me so far? Okay. Now on this sine theta equals 0, it's one of the quadrantals, right? Because you can't have a triangle with the side, so it's got to be one of those, right? And then sine is y, so the y is 0. So then sine ends up right here. This is 0, 1, and that's one of my answers, pi over 2. And here's another spot where it's 0, -1. So this is also a right answer, 3 pi over 2. I got 2 answers so far. Then over on the other one, it's tangent. And tangent is 0. That means I'm going to call it y over x. Is there a spot where y is 0 and x is 1? Isn't that the spot right here? I think so. And so then the answer for this one is 0. Those are my 3 answers. And then Mr. Server says, nope, you forgot the extraneous answers. 2 of these 3 answers are extraneous. When I plug them back in, I end up with tangent of pi over 2. The one you got to watch out for is tangent, because think about it. With tangent, do you remember the graph of tangent looks like this? Do you remember that this was pi over 2 and negative pi over 2? Do you get that tangent doesn't exist at pi over 2? Do you remember that graph? Do you remember we had a test on the graphs? Okay, so tangent doesn't exist at either of these two spots. I'll remind you what negative pi over 2 really is. It's this spot down here. It's 3 pi over 2. So, don't stay with me. This is a really important ending. So, when I've got these three answers, these two, when I plug them back into tangent, don't work. And therefore, they are extraneous answers. We'll practice this more, but your job tonight is to do 5 problems on a worksheet. The worksheet's got 14 questions. Do you agree I've cut it down a lot? Do those 5 questions, check it against the answer key, and then you'll be okay. And that's all I got for you for today.